Welcome back. We've already talked about what it takes to find the area of specific shapes. Conveniently, when you're given a geometry textbook, they give you a bunch of figures, trapezoids, kites, quadrilaterals, triangles, circles, polygons that are all the same. They're all just regular polygons just sitting out in space. Unfortunately, sometimes in life we have problems that just don't fall into that convenient category. And so what we're going to learn how to do today is find the area of composite figures. Figures that are made up of not just a regular kite or a regular quadrilateral, but figures that have a bunch of different elements together, and we need to figure out how to divide them and make them into something we can find the area of. The philosopher Aristotle said, "The whole is more than the sum of its parts." Well, when it comes to geometry, that's not true. That is not true. I'm going to call Aristotle untrue. The sum, when we're talking about geometry, the whole is the sum of the parts. For geometry. And I'm going to put this in quotes. Because in geometry, the whole is the sum of the parts. And we're going to help ourselves out by finding ways to divide up the whole into specific parts so that we can find the area of them. Alright, so here we go. So in example 1, when we start to look at these areas of these figures, we're going to notice that they're made up of various shapes that we already know how to find the area of. So for example, this red figure over here, I wouldn't necessarily know what that was, except for the fact that it's divided up into a triangle, a rectangle, and a half circle. So let's look at what we've got here in this first one and see what we can do to divide it up and make it a composite figure. Composite meaning it's made up of different parts. There's about as many ways to divide this as you could think, but I'm going to divide it something like this. And when I do this, I'm going to notice a couple of things. I have two rectangles. I know how to find the area of rectangles. I need to know the dimensions of these rectangles. Obviously, this one on the bottom is going to be 27 long, so I'll call this 1 and this is going to be 2. So rectangle 1 the length is going to be 27, and I don't know the width yet. What about rectangle 2? Well, rectangle 2 is going to be length 15, and the width is going to be 12. Well, I can already find the area of that one because it's 15 by 12. Let's do a little bit of simple subtraction to find what I need for the first one yet. If you notice, what I've got here is this whole thing is 21. Well, if this part is 12, I'm going to do 21, which is the whole thing, minus 12. So this is going to be 9 centimeters. So the width of this one is 9 centimeters. If you're not great with multiplication, or don't know how to multiply numbers that big, let's find the area of rectangle 1. Equals 27 times 9, which gives me 27 times 9 is 243 centimeters squared. Remembering, of course, that area is always in units squared. What about the area of rectangle 2? Area of rectangle 2 is going to be 15 by 12, which gives me 180. So to find the composite area, all I need to do is add these two rectangles together. So 180 plus 243 equals 423 centimeters squared. Normally this would be called a 1, 2, 3, 4, 5, 6, a hexagon. It's a hexagon, but because it's divided into two rectangles, I can find the area of it. How about for this second one? Let's take a quick look here. If I am thinking about this, I need to find some other values in here in order to find the area of this this figure. Let's think about this triangle. So the triangle is 1/2 base times height for the area. The rectangle equals base times height, or length times width. And the circle, it's half of a circle, so it's going to be 1/2 times pi times radius squared. Let's think for a second here. What do I need to know? If I look at this rectangle in the middle here, it already has one of its pieces outlined. And so this here is 3. So what does that make the back side of this triangle? Well, if I sort of like redraw this, and I'll just redraw it in miniature here, and this is going to be 4.8, right? Because if this part's 3, and this part's 3, and this is 10.2, the total of 7.8 leaves me 4.8 for this backside here. So the area of the triangle equals what? Well, I still don't really know what the bottom of the triangle is. Well, what could I do? I could use Pythagorean theorem. So I'm going to go 10.2 squared plus 4.8 squared. And I'm going to take the square root of that. The area of the triangle is 1/2 base times height. So I need to find this. Well, x squared, I'll call this x, plus 4.8 squared is equal to 10.2 squared. So I'll subtract 4.8 squared from both sides. 10.2 minus 10.2 squared minus 4.8 squared gives me x squared equals 81. So x is equal to 9. So this was a simple Pythagorean theorem problem with this right triangle. So if x is equal to 9, I know that this one's 9 also. So that makes this 4.5 for the radius, 4.5 for the radius. So then, I need to scroll down a little bit, I'm running out of room. The area of the triangle equals 1/2 9 times 4.8, which gives me 0.5 times 9 times 4.8, 21.6. What about the area of the rectangle? Well, that's going to be 3 times 9. 27. So in yellow here, I'm going to write this down. Trying to get the yellow. So this triangle is 21.6. This is 27. And what about my circle? My circle, go back to my pinkish purple. My circle is going to be 1/2 times pi times radius squared. So 1/2 times pi times 4.5 squared, which is going to give me 4.5 squared divided by 2, and that's going to give me 10.125 pi. So what's the area of my whole figure? The area of the whole figure is the sum of those three things. So here I go. I'm going to add 21.6 plus 27 plus 10.125 pi. And this is my whole area. So 21.6 plus 27 plus 10.125 pi equals 80.4 feet. Find the area of the three things. Add them all together. That's a composite figure. I'm going to let you do example C on your own. My suggestion to you would be to divide it right about here, and that's going to be a 90-degree angle. Try that one on your own. The other way that we can do this, composite area isn't just necessarily adding figures together. It might be saying this is part of a larger figure, but part of it is missing. And so in this first one, let's look at what we've got. Notice, if I drew this dotted line here, I would have a whole rectangle. So the area of the rectangle would be equal to 18 times 36, which gives me 18 times 36, 648. Unfortunately, I'm missing this little wedge-shaped piece, but it is a triangle, and this is a triangle that I know the base of and I know the height of. So minus area of triangle, which is equal to 1/2 base, which is 36 because this is 36, times the height, which is 9. So 18 times 9. So that's going to be 162. So my area is equal to 648 minus 162. 486 meters squared. Find the area of what's there if it wasn't missing the pieces and subtract back. On this one, I'm going to give you a hint. These are both half circles, and this is going to be a length of 16 here. My other hint is that 2 halves make a whole. 2 half circles equal a whole circle. Alright, so that's composite area in a nutshell. Thanks for watching, guys. We'll see you next time.